intention behind my bonus project was to help improve urban infrastructure by automating these parking lots building barrier systems a little more. So when a car pulls up in front of the barrier arm, a sound sensor will detect the idling vehicle, which will then activate the license plate scanner, or in this case the QR code scanner. And based off of the reading from the license plate or the QR code, it will open or stay closed. A motion sensor or ultrasonic sensor would have been ideal for the initiation process, but I just didn't think of it soon enough. For the first and second learning outcome, I'll use this flowchart to give you a brief understanding of my program. So once we run the program, it'll enter into a while loop here that tests the condition of the button, and if the button remains at 0, which is unpressed, it will continue to loop. Once it's pressed, it'll enter into the second while loop, and this second while loop tests the voltage across the potentiometer, and while it's not equal to 5, it will then run these functions here, which is to plot two live graphs, a sound voltage versus time graph and a servo condition versus time graph, and it also collect data of the servo condition versus time. Then we'll enter into a if statement, or a nested if statement actually, and this will test the voltages that come from the sound sensor, that are translated from sound, to see if they are greater than or equal to the threshold value. If it isn't, then the servo motor remains off and it just makes this loop back, and that value will be plotted as 0, or collected as that data will be collected as 0, no movement. And for the sake of the flowchart, we'll see that it was a greater or equal to the threshold value, so we continue on, and we get to this function. If it is greater or equal to, then the webcam opens up and takes a snapshot after 7 seconds. 7 seconds, the reason for that is because we want the camera to focus, and we also want to give the user enough time to present their QR code or for their license plate to be in the proper position relative to the camera, so that you can take a proper picture and scan it properly. For second if statement, that tests to see if the data that was read from the webcam matches one of the registered QR codes or license plates that is in an array within the contents of the program. It'll test to see if it matches any one of the registered QR codes or license plates. If not, then the servo motor will not activate, looping back and collecting that data as 0 over the time that happened. If it did, the servo motor is activated, and it opens for 5 seconds to give you enough time to pass through, and it'll welcome you with an audio and update the graph condition, and that will be 0.5, which means on or activated, and it'll continue that loop until you either reach max samples, which is I think 10,000, yes, or you turn the potentiometer all the way to 5. Then once you've done that, the loop will end, and then you'll get your plotted data. Because the data that we're collecting is so random, it's going to be hard to explain a trend going on in this graph, but we can talk about the relationship of the sensor itself to the sound, or the output voltage. So the output voltage is directly proportionate to the efficiency of the sensor, so how well the sensor detects sound and translates it to voltage, and the actual intensity of the sound itself, so how high, how low, or how soft or loud it is. And for the second graph, which is the servo or barrier state or condition over time, it looks somewhat like a negative sawtooth wave, where 0 is off and 0.5 is activated, and I guess it just kind of takes time to get back to 0, right? So I'm going to run you quickly through my conditional statements. This first while loop here allows us to begin the program. It checks the condition of the button. Once it's pressed, it'll end this while loop, bring us to the second while loop, which checks the voltage across the potentiometer. And while it's not equal to 5, it will run everything in here, which includes our if statement that checks the voltage readings from this graph up here that's being plotted from the sound sensor graph over time. And if those values are greater or equal to the activation limit, then it will open the camera, pause for a little while, take a picture, and whatever it took a picture of, it'll scan that data and input it into MSG. And this nested if statement here will test to see if MSG is a member of L plates. If it is, it will open the servo and play an audio, pause for 5 seconds, close the servo, and update this value right here. If not, this will remain at 0, and it'll continue to loop until it reaches max samples, or I turn the potentiometer to 5 volts. As you saw previously, I called this function as well as this function in my program, and really all it does is this plots the position of the servo over time into the subplot of the same figure, as this one plots the same into the same figure subplot for the sound graph, the graph that changes over time. So I'm going to run my program. This is to simulate the car noise, because I don't have a car. And see, I'm going to run this program here. It's not going to start unless I press the button, right? So if I press the button, Then our two live graphs pops up. I'm not sure why this is like this. I tried fixing it. It didn't work. I don't know why. But it doesn't really matter. So now I'm going to start the car. Graph pops up. Right. So now I can scan my QR code. So now we can begin to QR code.
Hi, how are you? On your way in. Can you tell my boss to please give me a raise?
And when the servo motor is activated or deactivated, it seems to surge. There seems to be a surge of voltage across the D3 pin. So that's why you have this spike here, and then right here you see this blank is not registered in our database. So I'm just gonna do some other ones. So this is also one that's in the database. Oh, sorry, I have to make a noise. Hi. All right.
Who are you? Just kidding. Welcome back.
Right, so you see this right here. This is the scan plate, and I'm gonna do one that shouldn't work. It shouldn't activate the servo motor. Hi. But and it says unregistered is not registered in our database. So now if I turn the potentiometer, I should get our final graph. So once we have these graphs, we can use the data for statistical analysis, maybe, or probability analysis, or for security reasons like seeing how many people, or just data collection, seeing how many people come into a building at a certain time of the day, likely it is for some people to come at one time or the other, stuff like this. Seventh learning outcome, we will begin the loop by pressing or begin the program by pressing this button. And once this button is pressed and this is not equal to 5, then our program will begin to run, and we'll begin to data from the sound sensor, and also take data from the condition of the servo motor. Then depending on what we get from here, our webcam will kick on. Then depending on what message you read from the webcam, from our license plate of our super awesome paper car, our servo will either go on or stay off, and this will read back to our Arduino and collect our data over time. Right here, the brown is connected to the ground, the red is the live or the input voltage, and the yellow or the orange here is connected to the D3 pin. And this will continue to loop, collect data, graph the plots until I turn this to 5 or the max samples is reached.